the May 11th meeting. Next month, which our meetings, our webinar meeting will be June the 8th, and we're going to be having Luke Chamberlain with Spartan Peripheral Controls talking about control valves and retrofit applications and new applications and stuff like that. So that should be an interesting talk. So June the 8th, mark it on your calendar. And the other news, I guess, nothing really too much going on other than this summer we'll be reaching out to everyone to try to get you to re-up for your membership, so that we can keep rolling through the fall winter time. And the membership dues help us keep everything churning. And again, I want to thank our sponsors who have been good about hanging in there. And so from what I hear, most of them have kept things going. If we did email out a copy of the magazine this month, and if you missed that, you can go onto our website, which is www.boacalgary.com, and you can download the magazine from there. Hopefully the magazine is on there. Did you put it on, Les? I don't know if you did or not, but anyway, Les will figure all that out. And I guess without further ado, I guess we might as well get this this good little talk going. So today we have our good friends from Ainsworth, and we're going to be talking about water-cooled chillers and what's new. So that's kind of a topic that's dear to my heart, and I want to thank you guys for being able to help me out here at short notice, because we had scheduled Gentech to do a generator talk, but they were not able to partake. So so thank you again for stepping up to the pump and helping me out, and as always. And anyway, without further ado, I guess the way we're going to do this is for the introductions, which is a little bit different than what we normally do, is Rick Hack with Ainsworth is going to do the introductions for his little group here. So he's got some chiller mechanics in the room, and so he's going to introduce everyone. And I think probably most of you probably know some of these characters for sure. But those that don't, Rick's going to go through and make up some lies about them and show their faces and all that kind of stuff. So take it away, Rick, and do your introduction.
Okay, thanks, Mark. I did build one a little bigger than what we had maybe originally talked about. But anyway, good afternoon to everyone. I want to thank Mark and everybody at BOA for giving everybody here at Ainsworth the opportunity to do the presentation on chillers today. My name is Rick Hack, and well, my thing's all messed up here. Is Rick Hack, and I'm introducing our topic and our main presenter. For those of you who don't know me, I've been in the chiller and HVAC and controls industry for over 40 years. And I served as a field mechanic and a manager with Train and with JCI also. And now I'm with Ainsworth. To tell you a little bit about Ainsworth, I'll throw in our little commercial here. We're a full service mechanical company with many different teams and many different types of teams. And that's all led by Don Schaub, who most of you have probably known through his days at Siemens and JCI and at Ainsworth for the last 8 or so years. People in the industry always tell us how surprised they are at the scope of work that Ainsworth is capable of, and how much service or installation we can do within a building. Ainsworth has many different teams. We've got electrical installation, we've got electrical service, we've got plumbing service, plumbing installation. We do boiler service, we do mechanical retrofits for chillers, boilers and mechanical systems. We have a tin team to do tin bashing. We can do energy audits. We've got BMS controls, HVAC and chillers. We can even supply building operators if you need it for a vacation coverage. It's not something that we do regularly, but we fill that need when somebody really needs our help. Our biggest team expansion in the last few years has been our acquisition of ESC Automation and the whole group of great controls people over at ESC. And when you see Sheldon's background, you'll see that we've got that GDI logo in the back, and on many of his slides, you'll see that ESC is on there. And it's just been a great thing for us overall to have that group of ESC people with us now. Our focus today is on our chiller team. With our new hires of Gary Gottwald and Sheldon Tetrault and Matt Compressors, we now have over 200 years of chiller experience on our team of 10 mechanics. And those are all 10 mechanics working on chillers all the time. As an independent chiller service company and the largest chiller service company in Calgary, we've got factory training from all the big original equipment manufacturers and additional training from most of the smaller manufacturers. And you'll see a slide later that shows all those different companies. I'm pretty proud of the team we've got put together here at Ainsworth. We started many years ago by Norm Denslow, as most of you would know, and it's now being led by Paxton Lang. Our presenter today that's doing the bulk of the work here is Sheldon Tetrault. Sheldon has an extensive background and experience of 25 years in chillers and HVAC. He's worked for Siemens, Trane, JCI York, and now he is one of our newest people at Ainsworth. He has a great list of OEM training on many different types of equipment, and he spent that 25 years in the field. We also have with us today, we've got Norm Denslow, we've got Paxton Lang and Gary Gottwald and myself all set up here to answer questions once we get to the Q&A piece. And so now we're just ready for Sheldon to take over and share his screen with us. Mute.
Mute, yeah.
Yeah, well, thanks. I am a chiller mechanic. I have a total of 0 PowerPoint training. So bear with me. Hopefully everybody can see that screen.
That looks good. Looks good.
Perfect, perfect. So yes, what's new? And water-cooled chillers, something I spend a lot of my time on. I find very interesting, much to the amusement of my family that maybe don't understand the excitement with it. But we're going to just go over each of these topics. You know, often we can do an hour presentation on. So we're just going to touch on a couple of things that are out there that probably you guys have come across. And if you're not aware, just make you aware. So there is a lot of machines in the marketplace now, and this is just some of the few. And here at Ainsworth, we do have the factory training on. A lot of us still call it McQuay, but Daikin, right? The York, purchased by JCI, Trane, Carrier, Smart, Arctic Cool, Multi-Stack, and there is more. So there's a lot to know. There's a lot of different brands, and I think at Ainsworth they've addressed covering all those different brands and their strengths and weaknesses of each one. So yeah, they have quite a large team. The fonts didn't quite work out on this slide, but this is just a lot of the guys, and like Rick was mentioning, a couple guys like Gary, Norm, Rick, Al, they've seen a lot of changes in the industry over the years, let's say. And we even at Ainsworth have Corey, who works on chillers down in Lethbridge, Medicine Hat. So it's quite a dedicated team of guys. So one of the first new things we're talking about and covering is magnetic bearing compressors and chillers, so often called mag bearing. They are very interesting, very, from my point of view, exciting, just because it is a revolution in how things are done. Again, a lot of these topics we can go on for great length. Like if you go for factory training, this is a week-long course. So we're just kind of touching on magnetic bearings, what it means, and just point out some of the big differences in the cooling plant you would have in your building if you have one of these machines. So there's a few different manufacturers. You know, there's the Turbocore, Danfoss, the WME from Daikin. York has a couple of different ones out there with their YMC squared or YZ, just different refrigerants, but they all kind of have some real strong advantages. And one is no oil. So there's no oil, no friction really. And without the oil, you don't have the oil maintenance, the oil changes, there's no oil filter to maintain. And there's no oil to heat in the off cycle. So a lot of you have found that, you know, if a machine is off for servicing, you need 6, 12, 24 hours to heat that machine back up and make sure the oil is nice and hot before you run the machine. With magnetic bearing or mag bearing machines, there is none of that. They also use, through the loss of the reduction in the friction, way less energy running. Like if you are used to watching an old machine and then you come across and you watch the FLA that these are drawing, it really is amazing what they do. And they're quiet. Any of us have worked in a room with a machine that's running gears or a screw, truly appreciate how quiet and non-disruptive to the tenants these machines are. There's hardly, well, often the pumps in the room are louder than these machines. And also if the system is working well, the flexibility they have in matching the load or the capacity control of the building is pretty wild, honestly. So magnetic bearing compressors, chillers, you guys are probably seeing them more and more, and that's you know, they've been around for a while, but they're definitely becoming more commonplace. There is a couple of things to be aware of with them. They do require more sophisticated troubleshooting often. There is a lot of components, a lot of circuit boards, a lot of different piggyback boards, a lot of things that are interacting all together. And so the training and the understanding on how it all works really comes into play with those machines. They also, you know, as a mechanic, I'll be speaking more as a mechanic than the engineering literature. Stable condenser water is also pretty important. There is no mechanical thrust bearings, so any of the surging or thrust is handled by magnets, and so surging is detrimental to these machines. It's not really an issue that comes up much anymore due to VFDs on cooling towers. Condenser water flow is typically pretty stable nowadays, but it is something to be aware of, that you know, chillers are part of a system, and having your chilled water cycle or system as well as your cooling tower and those pumps all working together really see some benefits in a building. So surging is tough for these machines. Oh, and we were going to go over any questions on mag bearings if anybody had any. My screen is just showing me mine, so
Yeah, I don't see anything yet, so
Okay.
we can always, if they do, we can just catch up.
perfect. One other thing is on the chiller construction. is a falling film evaporator. So it's not something we can see, but it's on the inside of the evaporator barrel or cooler, you know, depending again on the terminology you're using. But machines are being built with this falling film evaporator. When I went to school, I was taught this 10-10-10 rule, where you had 10 degrees Fahrenheit difference between your refrigerant and your leaving chilled water, and again on your condenser side. That's tightened up hugely. With falling films, you have much greater efficiency, you know, with the lower approach or small temperature difference with the heat transfer from the refrigerant to the chilled water. It's also uses a lot less refrigerant in the chiller, with not being flooded where the tubes are submerged. There's a lot less refrigerant being used. So as you guys are doing refrigerant management, and if you just look at the nameplates, some of the machines are going from where they had 2,500 pounds of refrigerant down to 1,200, which really is a cost savings on the machine itself, because that refrigerant does have, if any of you have dealt with a leak, it's not cheap. There is one thing to watch out with the falling film evaporator, is they do react differently, the different barrels, with adding glycol to the system. So if you have a chilled water loop and you want to put glycol into it to protect your chilled water coils, you don't always get great heat transfer with, you don't get the same style of heat transfer with a falling film evaporator. So that's one thing just to be aware of. With some of these great efficiencies, there is also just some extra items to be aware of when you're running your building. So condenser water temperature, that is another thing that comes up quite often for me as a service mechanic, is the, you know, a chiller is referred to often, just if there's cold water coming out of it, it's a chiller, no matter if it's 5 tons or if it's 2,500 tons. But each of those machines reacts very differently to the building system that they're in. So one of the things for efficiency and reducing energy cost is to lower your condenser water temperature. In the past, we would often raise the leaving chilled water set point. So raise it from, and I hope you guys are okay with Fahrenheit, but raise it from 45 to 50, say, to try and unload the chiller to save energy. Another way that we're doing more and more today is to lower our condenser water temperature. In the past, you would run it around 75, 80 Fahrenheit to help with the oil return. Or on a screw, you need that higher pressure in the condenser to help with loading and unloading of the slide valve. But with the lower condenser water temperature, you can really get some advantages. So, and a couple things to remember is that mag bearing chillers have no oil pressure to worry about, and almost every brand has compensation to run that colder condenser water. So with the lower condenser water temperature, you have lower condenser head pressure. So on the high side of the refrigerant circuit, the pressure is lower. And then the chiller, as a lot of chillers have VFDs on them now, you run at a much lower RPM to generate enough lift to get the same refrigeration effect. Now this topic I'm going over very quickly. I actually have a great PowerPoint slide that's quite in depth with pressure enthalpy charts and heat rejection and heat load calculations, but we're just kind of touching quickly on not every machine has the same cooling tower leaving water requirements. And that's something that's new, where almost everything would be running around 75, 80. Now, as there's all the different brands and all the different machines to optimize their performance, you know, we can adapt these set points to get more efficiency and a smoother running machine.
I have a question.
Sure.
What's the coldest condenser water you've ever seen a chiller running at?
Coldest was 36 degrees Fahrenheit. It was a machine that was running off river water, and it was left on through, and I have to be careful because you don't want to blame the automation since we're own ESC now, but yeah, no, they were running river water in the winter. The condenser was actually sweating. And with some of the new machines now, they can run them inverted. They're not necessarily more efficient that way. They still require a differential on the evaporator and condenser water pressure. But just a couple weeks ago, we were running, as part of a startup and commissioning, we were running 5 degrees Celsius condenser water in the machine, no problem. We've done other experiments with customers where their BMS was all set up in Celsius. So we were running 24 Celsius condenser water with the same load in the building, lowered it. They had a lot of cooling tower capacity, and you could literally watch the FLA drop on the chiller as we took the tower water temperature down to 14 degrees Celsius, where it was running about 8% less on the FLA. It's pretty cool. All right. So another thing that comes up is free cooling to mechanical cooling, and the switch over and how you pick that number. This is kind of an expansion again of the colder condenser water. One of the advantages of new machines is that you do not need the warm-up loop like you did in the past on the cooling tower. So where if you were switching from free cooling, in the past you would have to warm up the tower sump so that it would be, you know, in at least the 68 to 70 degree Fahrenheit range before you would enable the chiller. Now, a lot of the machines can handle switching straight from free cooling to mechanical, which so you in your building, there isn't that spike on the chilled water leaving temperature. It doesn't go from running at, you know, 50, spike up to 70 while you're waiting to turn on the mechanical cooling and then have the machine pick up the load and drive it down. You can go straight from using that, you know, as, you know, like we were just talking about, as low as, you know, 50, starting the chiller, loading it up and running it. So that is something that has changed and evolved, and it's just good to know. But it is specific to different types of machines. So depending what you have in your building, really affects how you do the optimization for the cooling plant. So how am I doing for time?
I have a question here that I should have asked in the. This is to do with falling film, so we'll just, because we haven't gone too much past that, let's just take a step back. So this question is from Kyle, and he's asking, assuming with the falling film there is a reduction in pump size, he's asking, and with all other equipment taken into account, how much savings or percentage does that result in?
The savings,
Yeah, so he's saying reduction in pump size, so.
well, as the system becomes more efficient, and I'm involved with the chiller itself, a lot of the savings come in with the refrigerant cost on the machine. And then with it running where you need less, let's call it refrigeration effect, to cool the same amount of water, because you're getting much more efficient heat transfer. So the pumps, the flow for the cooling coils is still the flow. The pressure drop in the evaporator is still a requirement that the engineer sets. So the pump itself doesn't necessarily change. So in some buildings, they'll size it where they're running a 440-degree leaving chilled water temperature, so that they're trying to get a higher delta T on the on the cooling system, so that they'll have smaller piping and that they'll have smaller coils, because they're trying to get that extra little bit of delta T. And that's where you might get smaller pumps, but typically with the falling film, it's more on the efficiency and the energy consumption of the chiller itself.
Can we talk a little bit about different efficiencies from older chillers to newer chillers, like in kilowatts per ton?
That I find a bit challenging, because what you see in the field and what you see on the engineering literature, there's so many variables, but the kilowatts per ton are getting down to like 0.3, like it's crazy. But that's something I don't focus on a lot, because just like sizing a cooling loop or condenser water loop based on the pump curve, it gets you close, but there's nothing substitutes for physically measuring it in the system. So that, that's where the field experience, I think, really kicks in. Because if you look at the engineering guide for each of the manufacturer, they'll tell you that that equipment will make you breakfast if you'll buy that chiller. It's a little misleading. The kilowatts per ton, they are, what I'll say is on the mag bearings, because we'll do an experiment, and it's a little bit easier on a York, because they have an open drive motor. You can disconnect the coupling on the compressor. We've done it where we've ran just the motor, and it will draw 19% FLA doing 0 tons of cooling. So if you take that out of the circuit, you can see a mag bearing machine run 5% FLA and still getting some effective cooling. So the kilowatts per ton doesn't come into my day-to-day too much, but I know they're getting the numbers pretty low on the new machines. It's pretty crazy.
Yeah, the part load on the mag bearing machines is phenomenal.
I have a mag bearing.
On part load kilowatts per ton.
Yeah, it's crazy.
And you can see it in real life too, because they match the load so much better. They'll pretty much back right off to nothing. Whereas the older machines couldn't do that because they were just closing vanes and running the motor.
And at a constant speed, right? And so to unload a chiller now, they'll change the speed of the motor. They turn so fast, but then back them down. It's it's pretty impressive on the new machines. Was there anything else on that? I know there was a pump question, but we can.
Oh, that was just basically the falling film question.
Okay.
I'll just check and see. Kyle says, got it, thanks. So I guess you did good.
He's very generous. Again,
Yes.
I
He's one of
don't
us.
do a lot of presentations during my.
He's one of our brothers, so it's all good. We look after each other, right?
Yeah, yeah. So, going next is the variable speed drive, and I think everybody's got a variable speed drive now. Everything's got a variable speed drive on it. It's hard to find a pump that you can't to buy one without a VFD. The VFDs are on the carriers, they're on the Daikyns, they're on the trains, they're everywhere. So they have a lot of pros where they greatly reduce the inrush current, which affects the sizing the breakers, which the wire size, everything. It's the inrush is way lower on the variable speed. It also doesn't generate that initial heat, so your cycling time on the compressor is you don't have that 30-minute time delay. You know, we've all been stuck where you go to start a chiller and then a flow switch sticks, or you got air in the system and then everything shuts down. You know, you address the problem right away, and then, you know, there's 30-minute delay before you try to start it again. Which meantime, the chilled water loop is climbing in temperature, you're getting calls. So variable speed drive, one of the awesome things as Mechanic is the cycling time is greatly reduced. As you're turning the RPMs down, you're using less power, and your kilowatts per ton do go down. And your capacity control becomes much more fine-tuned. So there's some real advantages, and you know, and there's more, and they're on almost every machine you can find now. So again, as a chiller mechanic, you use your meter a lot more, you become a lot more familiar with SCRs, IGBTs, you know, CTs. They're all part of our everyday now. Some of the things to keep in mind with variable speed, there's not too much, but it does increase the initial purchase price of your machine. They can be more expensive to repair just because, you know, I think someone told me, I've never bothered to count them, but that, you know, some of those VFDs have 20 boards in them, right? And each one has a cost to it. And they do generate some heat. It's typically not a big deal, but just something that does come into the engineering sometimes. So variable speed drives have hugely changed how we interact with the chillers as mechanics, and mainly in a positive way. They're allow for much more flexibility in meeting the load. So here is a topic for me that comes up a lot. As VFDs have become more affordable, they are everywhere, and variable water flow, and there's a VFD on every motor, and they want to slow it down. And I'll only exaggerate slightly in saying, when you're dealing with the controls guy, they'll just pick the number 30 and they'll set it to 30 because they want to save energy. They don't know 30%, 30 hertz, but they seem to like that number. But variable water flow can save you energy, but sometimes it's at the expense. You're saving energy on a 30 horse motor by using more energy on an 800 horse motor on your chiller. So variable water flow is great, But one of the things to keep in mind is it does require more sophisticated automation control with variable water flow, just like static pressure in your building. You change it too quick, bad things happen. So as that's come into plants, it's just something to keep in mind, and keep in mind that there still needs to be minimum flow rates for everything. Slow down the rate of change. You know, a lot of buildings are being built without a bypass. They just slow the pump down without considering how it affects the chiller. You know, the boiler too, but we're talking about chillers today. So it's something to keep in mind. And then varying the condenser flow. A lot of the Armstrong pumps or a pump unit will come with a VFD right on it. Condenser flow, varying it is not recommended. So it's just keep that in mind, as you know, it can be used as a soft start, but keeping in mind what the flow should be to serve the purpose that it needs is something to keep in mind.
Is there I have a question. Can I ask you a question? Is there a rule of thumb on how quickly you can change water flow on an evaporator?
There's a rule of thumb of a percentage per minute, but over the course that I would have to look up. There is recommended in the engineering guide for the machines. They do talk about how quickly to change it, based on the, you know, and you know, the feet per minute. There is quite a lot of information about it, and we usually just go as slow as the system will accommodate. So over the course of 10 minutes. But there is some calculations on rules of thumb on what percentage you would change it.
Okay.
So that can be found. That service guides can help you with if you want to fine tune something.
There is another question if you want
Sure.
to take a crack at it.
Sure.
So Godfrey is asking, how can we address or limit any occurrence of chiller surges?
So chiller surges, although it can be quite a few different things, it's often two things. Either air in your chiller, so you have a reduced condenser capacity, or too hot of water or not enough water, I guess. So three things from the cooling tower. So addressing the surge would be making sure that the cooling tower is optimized. It often gets overlooked. It's outside. It's just sitting there minding its own business, and it often gets ignored. And you'll have a problem with the cooling tower where the spray header is disconnected, or the fill is plugged, or the screen is restricted. So, or the strainer on the pump system. So having good cooling tower maintenance and a clean system addresses most of that. And then having an effective control strategy. You know, in the old days, fans would be on off, and there'd be a set of dampers for the cooling tower. And if you were lucky, there'd be a bypass where you could bypass the cooling tower to control the temperature for the chiller. But now there's VFDs on those fans almost always. And if they're programmed to have a great feedback loop, they can stay ahead of the load and that's being generated by the chiller, and have an effective temperature to the machine to cool it. The surging is usually that the pressure on the condenser side is, the pressure is too high because things are too hot. Does that kind of cover it, I think?
Yeah, I think that's a good answer.
Okay. This topic on the new refrigerants, you know, put it in there because it's real, it's happening. I find it difficult to get very exact information, but on what it means for us as mechanics. But the fact is HCFCs, so R22, R123, they're being phased out and production has stopped, like according to the Montreal protocol. So if any of you guys remember with R11, you know, there would be a clock that started if you serviced the machine. I haven't heard of anything like that yet, but those rules keep changing. And, you know, even in preparation, I reached out to a couple people and that spend a lot of time on the refrigerant rules that are coming. And it's hard to get exact information, but 134A has no phase out scheduled, but there is a reduction in production scheduled, which will result in a higher cost for R134A. So that's just something again to be aware of. There is replacement of R513 that's out for 134A. You know, again, with a lot of the new machines, it's a pretty smooth retrofit. The 513 right now, last I heard, was pretty cost prohibitive, and that's why new machines haven't been coming with it. But if there's a need, most equipment can be retrofitted pretty smoothly. But so the R134A, it's not going away. There's no phase out scheduled, but it is considered a greenhouse gas. New low pressure refrigerants are here. The 1233ZD and the 1234 YF, I believe it is. There's new equipment coming with it. I think quite a few of us have gotten some training on it, and when that equipment hits the mechanical room, we'll be ready. But that was just something to touch base on. So again, on the topic of new things coming is chiller integration. So by that, I mean integrating with the building management system. Most equipment is BACnet compatible. There is other strategies with LAN and Modbus, but it is something that almost everything is compatible. It can be integrated into your BMS, and you can really optimize the cooling plant to save some energy. So that is something, again, as a chiller mechanic, I'll be as bold to say it would be awesome to be involved in that strategy as they refine the building management, is to be able to put our 2 cents in on what actually helps the chiller be more efficient versus as opposed to just hooking a computer up to things and hoping for the best. So that is something, and there is some and it is demanding to be more sophisticated. So that's just something to throw out there. So again, a little commercial they threw in here on all the skills and services at Ainsworth. Some of our key goals and questions.
There is one more question here from
Sure.
Godfrey. Well, there'll be at least one, but anyway, this is the latest one from Godfrey. Is there any regulatory requirement regarding leak test of the refrigerant piping system in frequent basis, quarterly or annually?
So federally regulated buildings require it to be checked every year, and they have very specific paperwork that we would help you with. there is things that come up with insurance companies and also the province on showing diligence, but an annual leak check and tagged is on a federally regulated site is required. On the rest is strongly recommended for, well, for many, and even just for the health of the machine to manage the cost of the refrigerant. You don't want a leak going because depending on what refrigerant it is, it can be very expensive to replace it, and you want to catch that as soon as possible.
Okay, I probably got a few comments here, maybe Les has a few, but one of the things that one of the challenges I wanted to sort of talk about was these days with buildings having variable loads, variable occupancy,
Yeah.
how that's affecting everything. And also the fact that our loads may change because we're bringing in more outside air when it gets hot. We'll see what the summer brings, because I mean, we're not doing the return air thing as much as we used to. So it's going to change the load, and so it's very depends on the building and what how the building is configured. But did you run into any of that last summer, and or what do you foresee coming up here for this season?
Well, I'll let some of the other guys speak up on that too, but for myself, I found in Calgary, because it's usually dry and not very hot compared to a lot of the markets around the world, there's usually lots of capacity in the machine. Actually, one of the bigger challenges is when we're running outdoor air, and you're running outdoor air that is colder than your leaving chilled water set point, the machine has no load on it. So that it's actually the opposite. One of the challenges is where the chiller will be extremely unloaded until it gets really warm outside. The humidity, again, we're pretty dry, so you don't have that latent heat that you got to deal with and condense off the cooling coil. But there has been a lot, as you're running more air, you're bringing in more moisture into the building, and condensate drains need to be cleaned. Again, that doesn't, on the chiller, there's been very few machines that haven't been able to handle the load. I don't know, what you guys?
Exactly what you said. We did see it last year on a few buildings where in the mornings when it's cool out, people trying to bring in more outdoor air, it was cycling a lot more than it used to. But on the local high end side, when it's warmer out, most of the chillers in Calgary are actually on the large side. Very few of them are undersized.
Yeah, could you guys hear there?
Sorry, one of the nice things about the new equipment as well is they'll respond to those changes much more rapidly than some of the older style chillers.
Yes.
Oh yeah.
The mag bearings could back off. The older chillers just cycle on and off.
Yeah, like the mag bearing, and then they stage, like that's what's nice about some of the little ones with the Danfoss is they can stage with that low load really nicely, and that's one thing we found.
At very high efficiencies as well.
Yeah.
Yeah, and so sort of further along those lines, and I know and understand your like for BMS. So one of the things that usually happens on at least more so on new builds than retrofits, but as a cost savings, a lot of times, or maybe it's somewhat of a ignorance from the engineering community too, but or they just don't know any better. But usually BMS systems very often lack the sensors to do a proper load calculation, and therefore are not able to tell the chiller when, how hard to run and when to run very effectively. I mean, they're trying to do it off of outdoor air temperature, which is ridiculous. And so it's surprising here, this is 2021, and we're still dealing with the same problem, whereas we did in 1986. You know what I mean? And
Yeah.
so,
Well, no, I'm totally with you. Like, I say it jokingly because I have worked at, every company I've worked at has had a control department, and they're awesome, awesome guys. And you guys have probably seen the spec yourself. Control as per industry standard. And this will be a $250,000 project. And that's the help these control guys get, right? Is, as per industry. Well, what's that mean? So there is a lot of really smart control guys out there. And it's just taking advantage of that. Because like you said, I was involved in a job. It was a retrofit. And again, they're running off theoretical pump curves from buildings or from pumps that are 20 floors away. There's so much pressure drop in items. Like it's so hard to, nothing makes up for measuring at the device, whatever it is. So no, it's the same. But as the chillers run on a finer and finer line, well, like I said on the VFDs, I'm trying to be a little bit political about it there, but they'll shut off the flow to the chiller, and then we'll get a call that the chiller is not working. Well, there's no water going through it, right? But that pump is super efficient right now. It's just nothing's working.
So
The chiller is efficient too. It's just there's no water, right?
yeah. And so what kind of goes with this is obviously there's room for or there's value in recommissioning so that you can take advantage of some efficiencies of operation that got missed on the build.
That's
And
exactly
so-
right, Mark. The technology, the capability is there. It's to come back later and spend the time to get that programming to get those efficiencies. You're exactly right.
And it's huge money. I mean, these things are not cheap to run. And so it's probably the biggest bang for the buck that I know of.
Agreed.
And so, and that goes for the controls as well. So it's now that there is the integration. I mean, I know the building I just worked in had integration available. It wasn't used that much to my after the build, but then that could easily be expanded upon. It's all there. Just
Oh, lost you.
Is our time limit up?
I don't think there's a time.
One thing you might want to throw in there is, scans we're talking about.
most expensive piece of equipment in the building.
We lost you for a bit there, Mark.
Yeah, there's cut out there for a minute.
Oh, well, I was just yapping, so.
Yeah.
We got your point.
Well, I know it went a little over, and I'm really, it's not what I do with the presentations, but the chillers are exciting. And this is one slide that I asked to have it put in, is to contact us. And once this COVID is settled down, set up a lunch and learn. We can do some one-on-one, talk about these things that are in your building. We'll get Rick or Norm to crack open the visa to buy some pizza, and we can talk chillers. And it's a little easier than this presentation. A little more specific. But yeah, that is something, if we haven't done it for you before, keep that in mind. Call Norm, call Rick, and and get him out there.
So I'm disappointed that you didn't get Paxton's face on there, but it's all good. I didn't get a chance to throw anything at him, so
Well,
maybe
here
that's
we can
just as
switch
well.
spots, and then Paxton loves questions. I'm all into that. You just Rick can throw some more of his kilowatt or some engineering questions at him, and yeah, here he's got
So-
something to say, Mark.
You want to give me a hard time, Mark?
Oh, he got mad and went away. Oh, look at this.
How's it going, buddy?
Substitute.
So hiding in the weeds as usual. I see.
I'm a little shorter than Sheldon, so you're gonna have to- How you
Well,
doing?
no pressure because I mean, the presentation has 2 minutes left. So, I mean, you had to get your smile in there.
That's right.
And,
One of the things,
oh, look at this.
one of the things you had mentioned about recommissioning is actually a very good idea in collaboration with the operators. Probably about a year into it works best because you guys start learning the building and we come in and make the changes together that actually ends up working quite well.
Yeah. Yeah. Unfortunately, at the last place I was at, we never got a chance to finish that off. But one has to always hope that some others take on where we left off. But who knows? Yeah.
Yeah, Kevin's got some questions for sure.
Well, again, guys, I appreciate your involvement. It was a good little talk. Sheldon did a good job, and I wasn't sure who else was in the room there, but close enough. I appreciate it very much, and I'm sure if anyone has any more questions, they know how to get a hold of you now.
For sure. Yep, and feel free to use those phone numbers if you guys have any questions. We always answer our phones. So
All right. Well, thanks very much, my man.
good to see you
Have a
again.
good evening. Have a
Thanks,
beer on
everybody.
me.
Will do.
And
Sheldon
thanks.
one now for making them do-
well, actually, Sheldon probably deserves a scotch. So there you go.
Yeah,
Yeah, exactly.
So I appreciate it very much, and thanks again to Rick and Norm, and I thought it was a quality little chat about the misunderstood world of chiller mechanics.
We're special.
much longer talk.
I guess that's another topic, isn't it? Yeah.